My name is Mark Webster, presenting for cs470 on cloud development. As I said, my name is Mark Webster. I'm an STE at Q&A, a software company. This presentation will cover how we deployed a full-stack web application from local storage to the cloud and took advantage of various cloud-based services in order to expand the functionality of our web application. So how do we deploy a web application? First off, well, we need to containerize it. So Docker allowed us to bundle our application code along with resources and any dependencies it may need, and we can build that little bundle, and that bundle can be run on anywhere via virtualized hardware. So we used our we created our Docker images, and we were able to upload all our stuff to Amazon Web Services and have it run in the cloud. Now, there are two application migration models, as you can see here in this figure from Resolute. Lift and shift, which is where we just move all the application logic just moves over, we run it as it is, and then we can re-architect or refactor, where we can take advantage of everything that the cloud provider offers, and we can build custom features, etc., taking advantage of all those tools. So we started off really with lift and shift. We built the web application, we moved it to an S3 bucket, which I'll talk about later, and we could have just run it from there. But what we wanted to do was take advantage of all the cool tools and services that Amazon offers. So we really did wind up re-architecting some things to take advantage of those options. Docker Compose allows us to have multiple applications running on the same time using containers. So we can containerize each web application, or each application in general, pardon me, and when we can deploy those, we have that YAML file, which has everything sort of instructed out on how everything's going to run and interact, communicate, and then we can run multiple applications at the same time to achieve a collective goal. So we wanted to move to the serverless cloud. Now, what does serverless mean? That means that we do not have to maintain any physical server space for ourselves. The cloud provider handles all the hardware infrastructure, maintenance, outage response, updating hardware, etc. Things move very quick in the tech sphere, and if we needed to keep up with demand, we might have to look at upgrading our hardware every year, perhaps even multiple times a year to scale with demand, and just the latest and greatest hardware rather. The S3 bucket, which we stored our initial web application files in, this is Amazon's simple storage solution. It's a cloud storage solution with virtually unlimited storage space. You pay for how much storage space you use, and it greatly benefits us because if we have to maintain the local storage, what happens if our network goes down? What happens if there's data loss? With Amazon, there are redundancies. They have a full team handling all this stuff at all times. And as our user base grows, the infrastructure will grow with that demand. So we don't have to worry about upgrading our own hardware. So we used two tools in Amazon Web Service, API and Lambda, to add on new features. So the API gateway acts just like a normal gateway. It connects endpoints, of our web application, the HTTP endpoints, pardon me, where users want to interact with the website. Requests are sent to our backend via the API whenever a user interacts with the front end, and the backend will then return a response in usually a JSON format. So in our case, we configured the Amazon API gateway to call Amazon Lambda functions. So those are custom functions that are called only when specified. So we don't have them running all the time, and they just interacted with our backend storage, and we use those to ferry question and answer data from the backend to front end and vice versa when we used user edits, etc. For example, we used the find one question, which just pulled a random question from the database. We used upsert, which updated, or inserted an answer into the answer table if it didn't already exist. And essentially, we were able to have our front end, have our back end, and then get in the middle there with our API and our Lambda functions to build that bridge to shuttle data back and forth between the front and back end very easily. As I said, DynamoDB was the database that we use. It is an Amazon product. I've used MongoDB in the past. MongoDB is platform agnostic. It could be used on any cloud provider. Dynamo is an Amazon exclusive, which worked in our favor because it's able to easily be integrated with everything else that we use. And it returns that JSON format, which is pretty universal. We created those CRUD queries, create, read, update, and delete, which could read the table items, delete the table items. We could write in new table items. As I said before, upsert, updating or inserting if not existing. Various functions where we're all able to connect our front end and back end. So elasticity refers to how the services provided by a cloud provider can grow or shrink as necessary. We don't need the computing power of Facebook if we have 100 users, but you never know. We might get to that point. So the cloud providers allow us to scale up as our demand grows, as our needs grow, our infrastructure grows. And then the pay-for-use model means that when we are that small 100-user application, we're only paying for what we need. We're only paying for what we actually use. The free tier of the API gateway is free up to 1 million API calls a month. Lambda functions are charged a small pittance per each time that the function is called. And then S3 charges per unit of storage utilized. I can't remember if it's 25 or 50 gigabytes, but it's very, very low cost. In terms of security, Amazon IAM, which is Identity and Authentication Management, allows us to really get down to a granular, fine detailed level and control not only who can access certain system resources, but even what system resources can access other system resources and do. So to do that, we created roles. So a role is just an identity that can be authenticated. It could be verified. And we wrote policies. So policies are just a statement of, shall we say, the rules, which tell AWS, what each role can do, what each identity is authorized to do. We created policies for pretty much every aspect of the application, and then they can all interact with the limits that have been placed on them. So for example, with our API, the endpoint of our API gateway, they could only call the Lambda function that we allowed it to. So if a user is trying to input a new question and answer into the database on our web form, then the API can only call the Lambda function that, for example, creates questions in the question table, question entries. The Lambda function can only interact with the table that we've specified in our policy. And the read permission, for example, that we gave the S3 bucket in the very second week, allowed for it to be publicly accessed, but also read by other logic. So in conclusion, cloud development is inexpensive, especially when we're first starting off and we're paying for what we use. And as we grow, it'll scale way better than in-house solutions. We don't have to spend a lot of money on updating our own hardware. Amazon takes care of that for us. The API gateways, we can just custom build a RESTful API or any type of API that we want to connect all our different components and build custom functionality. And in terms of security, Amazon Web Service is top notch. They are the backbone of the internet. We can get down to a really fine detailed level and control who and what can access what system resources and areas. And I think that given that all these things, the migration to the cloud for our web applications is going to benefit Q&A immensely. Thank you for your time.